All right, hello everybody. Today we're going to be in section 1.7, solving the absolute value equations. So here we go, and let's get ready to rock and roll with this. All right, absolute value is basically it's the distance a number is away from zero, okay? So if I take, say, here's 0, okay? Here's A. Now most people know that if I do this, this is considered the absolute value of A, which is going to be a positive result. Okay? But say I go to the other side of the coin and say negative A, and this is where, oh, that looks like a 9, so that's terrible. So let's say I go to negative A, okay? And a lot of students will say, well, gee, then that distance is also negative A. But it's not, because remember, there is no negative distance in this realm of reality. That doesn't make sense. Walking backwards does not count as a negative distance. So believe it or not, the absolute value of negative A is also positive A, okay, because distance cannot be negative. So that's basically what the absolute value does. All right, so now the steps involved in solving an absolute value equation is we have to make sure the absolute value is on the left. That's step one. Just like we're going to treat the absolute value, okay, like variables of an inequality. They have to be on the left side of the problem, okay? Step two, we're going to rewrite the equation without the absolute value using an or statement, or what I usually call this is the dark side of the problem. And you guys will see why in a few minutes. I'll explain that. Okay, then we're going to solve this, the both pieces out. Then they want us to graph, which is a little silly, and I'll explain that. And then we write our final solution. Okay? So those are the steps. Again, jot those down, pause the video if you need to. But again, these steps here will be incorporated in the problem-solving slides in the next sets. All right, so here we go. All right, let me shrink this down. Okay, so we've given the absolute value of 5. So the first things first, is the absolute value on the left side of the problem? The answer is yes. Now, rewrite the absolute values with using the or statement. Okay, because this will represent a compound inequality here. Okay, and all our equals is or. We're going to be using our statements are going to be based on the inequality, or the equals or the inequality symbol this time. So since it's equals is always going to be or. Okay. So we're going to start by rewriting the absolute values. So we start the first one, because the absolute value is alone, we're just going to start the absolute value of x is equal to 5. Or, now, here's where we do the dark side. Okay, now the dark side comes along the fact that this here represents the positive A that we talked about in the beginning. What's going to happen over here is going to represent the negative A that is also equidistant or same distance away from 0. Okay, so to incorporate the negative, we take the original problem, the absolute value of x is equal to 5, and we put negative 1 in front of it for this negative right here. Okay, now that we've done that, now we can take down the absolute value bars and start solving this. So I'm going to rewrite this with the bars down as x is equal to 5. Then that's all done. Or, now with this, I have to divide by the negative 1 first, because I got to get this out of here before I can deal with the absolute value. So we're going to have the absolute value of x is going to equal to negative 5. And then evaluate. So I break the bars, x is going to equal to negative 5. Okay. Now, then what we have to do is we have to check our final answers with our original graph here, or our original problem. Okay, so let's go over this. And the reason why we have to do that is sometimes these equations lie to you and give you a false answer. So here we go. Absolute value of 5 is supposed to equal 5. Snap the absolute value bar, 5 is equal to 5, so you know you're good. That's okay. Come over here. The absolute value of negative 5 is supposed to equal to 5. Again, we go back to the original one. We don't use this one, okay? So now snap the absolute value bars. 5 is equal to 5. So we know we're good. Both answers work. So now here's where the kind of annoying part's going to happen here, because this is kind of silly. Okay, we have to now graph this. Now, this is one of the few times I say you don't have to use my 3-line trick with this, but I'm going to demonstrate it on this one as to why we don't have to, and then after that I'm not going to do it again. Okay, so we're going to put our answers on the line. We're going to have -5. Remember, the smaller answer goes to the left. +5 goes to the right. Now what we're going to do is we're going to graph x equals 5. So we're going to put a dot at 5. X equals -5, dot at -5. Now if you remember from our compound inequality video, this is an OR statement. So we're going to use mashed potatoes and mush the originals to the final. So this one mushes down and just becomes a dot. This one mushes down and becomes a dot. So, and this is where my students will say, well, gee, what's the point of this if it's just 2 dots that I can just put on the line? And that's where I fully agree with you guys. And I say, you know what, if you want to forego this step with an equation and just do this stuff, you're more than welcome to. Now, our last step, we have to declare our final statement. So again, that's where we're going to look at what we had. So we're going to look at this right here and just put it in order because it's an OR statement. So we're going to declare x is equal to -5 or x is going to equal to +5. And there's our final statement. All right, let's go to the next question. All right, I'm going to shrink this down a little bit so we got room to work. All right, so here we go. Step number 1 says we're going to isolate the variable to the left. We're on the left and it's alone, so we're good. Step 2 then says we're going to rewrite the equation with an OR. We're going to do the dark side of the problem, as I call it. So the absolute value of 4x minus 12 is equal to 28, or -1 times 4x minus 12 is going to equal to 28. Oh, come on, you. There we go. Okay, so now that we have this, now we're going to solve both equations. So I take the absolute value, and be careful. This right here does not come out as plus. It stays as it is. So 4x minus 12 is equal to 28. And we're going to solve it. So add the 12. Oops, let me change color here so we know we're doing different things here. So let's add 12. So 4x is going to equal to 30. Correction, that's going to be 40. I'm sorry, 40. Let me get rid of that. That looks terrible. There we go. That's better. All right, now divide by 4s. So x is equal to 10. Wonderful. We got one solution. Now I have to do the other side. So I'm going to divide by -1. So we have to do the absolute value, 4x minus 12, is equal to -28. Okay. Take down the bars. So 4x minus 12 is equal to -28. Again, remember, this does not come out as a positive. It stays as negative. We're taking down the absolute value bars. We're not evaluating absolute value. All right, so now let's solve this. So add the 12s. So 4x now equals, that's going to be -4 or 16, sorry. And divide by 4s. So x is -4. All right, now I'm going to shrink this down a little bit, because I now have to check my solutions. Now we're going to take these answers and put them back into the original problem. We don't use the dark side here. Okay, so absolute value of 4 times 10 minus 12 is supposed to equal to 28. Absolute value of 4 times 10 is 40. Now remember, your absolute value rules state you cannot snap the absolute value bars until there's one number left inside. Okay. Now let's take down 40 minus 12 is 28. And now take down the absolute value. 28 is equal to 28. So we know we're good there. Go to the other side. Absolute value of 4 times negative 4 minus 12 is equal to 28. Sorry. Again, we don't use the dark side equation. Times this absolute value of negative 16 minus 12 is equal to 28. Again, remember, you cannot take these bars down until there is one number left inside. So we have to do the work inside. Evaluate. Negative 16 minus 12 is negative 28, equaling 28. And now snap the absolute value. And the absolute value of negative 28 is positive 28. And checking our answer, we're good. So both answers do work. So now it comes to graphing. Now, like I said earlier, I'm not going to do the 3 lines here. I'm just going to do one. So we have a coordinate at negative 4. We have a coordinate at 10. Okay, so I'm going to put a point at negative 4. I'm going to put a point at 10. And now we declare our final statement. So x is equal to negative 4, or x is equal to 10. And there's that one. All right, let's go to the next one. All right, now this one, we've got some extra garbage to worry about first. And it says absolute value has to be alone on the left. Well, it is on the left, but it's not alone. We've got this garbage. So we got to get rid of that first. So first thing I'm going to do is going to minus the 7 out of there. So negative absolute value, x minus 5, is going to equal to negative 4. Now, because there's a negative 1 here showing me multiplication, I'm going to divide by negative 1s. Absolute value, x minus 5, is going to equal to 4. Now, the nice part is, when I go back to check my answers, I don't have to go back to this. I can start right here. Okay. All right, so now that we've got the thing isolated and alone, now we can rewrite our statement with the OR statement. So we're going to do absolute value, x minus 5 is equal to 4, or the negative 1, the dark side of the problem, x minus 5 is equal to 4. Okay, so now at this point, let's start solving. I'm going to take down the bars. X minus 5 is equal to 4. Add the 5. I'm going to change colors here. I think I should. Add 5. So x is equal to 9. Wonderful. Now we come over to the other side, the dark side. Let's divide by negative 1. So x minus 5 is going to equal to negative 4. Now I'm going to take down the bars. So x minus 5 is equal to negative 4. Add 5s. So x is equal to 1. Okay, now that we have it here, we've got to check our solutions. All right, so let's put these in and see what we get. Okay, so I'm going to use this equation right here because all we did was alter its appearance by moving pieces. We didn't evaluate anything. Absolute value of 9 minus 5 is supposed to equal to 4. Absolute value of 4 is equal to 4. Whoops. Evaluate the absolute. 4 equals 4. So we're wonderful here. Now come over here. Absolute value of 1 minus 5 is supposed to equal to 4. Again, remember, I do not use the dark side equation. I'm going back to this one right here. Absolute value of negative 4 is equal to 4. Absolute value of negative 4 is positive 4. So again, we know we're good. So I can plot both solutions. So on my number line, I can do 1 and 9. Okay. And then we're going to put our points. Okay. And now just declare the final statement. So we're going to say that x is equal to 1 or x is equal to 9. There we go. All set. All right, let's go to the next one. All right, so let's take a look at this. Looks like there might have been a typo here. I think this is supposed to just say 4x. All right, so we'll ignore that little liney thingy here. So first things first, isolate the absolute value on the left. It's alone. So this thing over here is alone, and it is on the left, so we're good. All right, so now let's declare our statement. So absolute value of 2x plus 12. No, I don't like how that looks. Let me fix that. That looks terrible. Try again. Absolute value 2x plus 12 is equal to 4x. Or negative 1 absolute value x 2x, plus 12 is equal to 4x. Okay. Now let's start solving. So we take down the bars. 2x plus 12 is equal to 4x. Okay. Now since I'm solving an equation here, I can have the variable on the left when I'm doing this part. The variable just can't be on the left when I'm starting with the absolute value. 12 is going to equal to 2x. Divide by 2. So 6 is equal to x. So we're okay here. Now let's come to the other side. Let's divide by negative 1s. Okay. Absolute value 2x plus 12 is going to equal to negative 4x. Take down the absolute. So 2x plus 12 is equal to negative 4x. Minus the 2x. 12 is equal to negative 6x. Divide by negative 6. So negative 2 is equal to x. All right. Now, here's where it's important. This is a great reason why we check our answers. Let me shrink, if I can shrink this. Come on, you. There we go. We're going to shrink this down, and then we're going to check, and this is why we do this. Let's do the first one. Absolute value, 2x plus 12. Oh, hold on. Let me start that again. Let me clear that out. Because we already know what x is, so why am I writing x's? Absolute value of 2 times 6 plus 12 is equal to, now I got to put the x over here too. So 4 times 6. Absolute value of 12 plus 12 is equal to 24. Evaluate in here. So absolute value of 24 is equal to 24. And when I evaluate the absolute, does 24 equal 24? Yes, it does. Okay, so there's this one. But when I come over here and I start, absolute value of 2 times negative 2 plus 12 is going to equal to 4 times negative 2. And again, remember, I used the original problem, not the dark side problem. So absolute value of negative 4 plus 12 is supposed to equal to negative 8. Absolute value, negative 4 plus 12 is 8, equaling negative 8. Evaluate, 8 equaling negative 8. Uh-oh. Does 8 equal negative 8? The answer is no. So again, this is an example where this equation lied to us. It gave us a false answer, so we had to throw it away. Okay? So the solution of x equaling negative 2 is gone. I can't use it. It's no good. It created an invalid answer. So in this case, the only solution I have is this one. So that's the only thing we can graph. So when I come back up here, we're going to have at 6. I'm going to have my dot at 6, because that was still true. And now we declare our statement. Well, the only thing we have is x is 6. So our only statement is x is equal to 6. All right. And we move on. All right, so that's the end of this video. Hopefully you learned a lot, and I will see you next time.